Hello, here we are. We're in Algebra 1. We're finishing up the second learning target, which is about lines. And today we're going to use all of our information about the different forms of a line, forms of the equation of a line, to write some answers to some story problems, set ourselves up for a problem-solving task in class later, and then also the exam next week. There are basically three different kinds of pieces of information you can have going in. The first one we're going to do is when we know a starting value and a rate. As a reminder, the rate is basically a word meaning slope. So the starting value, as you likely know from middle school, is y-intercept, and the rate means slope. So let's look at this first example. Here we have Kenny. He has $8, and he's saving $15 every 3 weeks. We're going to define two variables, write an equation that models Kenny's savings over time. So first off, we need an independent variable. Good old independent variable. As a reminder, this is what you should probably think of as the x. It's the thing that kind of changes whether or not you want it to. And here we're talking about the time. So I'm going to call it t for time. And just to be crystal clear, we're going to include units of measurement. So the time in weeks. It is not important that you use the letter T. I'm using T. If you want to use something else, like a happy face or who knows what, some sort of strange emoji, whatever. But you just have to be consistent and use that forever going forward in this problem. All right. So then we've got the dependent variable. The dependent variable is the other variable, and that is what you should probably think of as the y variable. It's going to end up being graphed on the vertical axis, and it is the thing that changes after the independent variable changes, meaning when the independent variable changes, that changes the dependent variable. Okay, so we're going to call this M for money, and again, we need some units. So we've got the money saved, and we'll put it as in dollars. So there we are. Now, before we actually write the equation, I want to make sure we highlight the important pieces. So first of all, the slope, which is the rate of change. And here it's 15 over 3, because he's saving $15 every 3 weeks. And that can be reduced in this case to 5. So you might want to think of it as 5. It's written as 15 over 3. Then we also need the starting value. And remember, this is basically the y-intercept. And it still is basically the y-intercept. And that's 8, because he currently has $8. Okay. With those two pieces of information, we're going to write our equation. M equals 5t plus 8. M is the dependent variable, equals 5, because that's the slope, times t, because that's the independent variable, plus 8, and that's the starting value. Now to make a graph, we need a grid. So boom, and I'm rewriting it here because I need to write it so I can see it as we go forward. You already have it written down. Right, now go ahead and start to label the axes. The horizontal axis, the independent variable, is t. The vertical axis, going with the dependent variable, that's m. And then go ahead and scale the stuff. On the independent axis, we can go by ones. It'll work out just fine. On the dependent axis, though, ones won't really work. We can certainly plot the 8, but then it's going to go forward up 5, and that's not going to work so well. So let's go by choose. Then we can plot the dot of starting value of 8, and then a slope of 5. So up 5 over 1, up 5 over 1. Remember, each of the vertical boxes is worth 2. So that's why it's up 5, even though it looks like only 2.5 boxes. And then zoom, line with an arrow. Notice, though, I did stop on the axis because it didn't necessarily go back in time. If you think we can go backwards in time for Kenny's money, you can go ahead and make it go backwards also. That part isn't terribly important. You can have it your way. All right. Next example is a different set of information coming at you. This time we know a random point, so not the starting value. And we do know a rate, and a rate, again, means slope. So here, we got Alex, who's bulking up, And the independent variable is going to be time because her bicep diameter is changing over time. So we got time. Again, I'm calling it T. So there you go, time. And again, I recommend you consider this as being in weeks. Please include the units. It helps people understand what you're actually talking about. All right, we got the dependent variable. That's, again, what you should think of as the y variable. So here, what's going on? Oh, yeah, she's bulking up. Her bicep is getting stronger, getting bigger. So I'm going to call it B for bicep diameter. You can call it whatever you want. Make your favorite other symbol if necessary. This, though, is measured in centimeters, so please make sure to actually include those units. All right, now, here, we do know the slope. She's gaining 0.5 centimeter per week, so the slope is 1/2. That's not so bad. Now, we also need a point, because if you don't have some sort of location, you're pretty much stuck on a line. And here, though, it does tell you the diameter is 3 centimeters after 5 weeks. So since the time is the independent variable, that'll go first, so 5, 3. Now, with a slope and with a point, we can change those into point-slope form. B minus 3 equals 1/2 times T minus 5. Just remember, we got like y minus the y value. Well, here B is dependent, so it's B minus the B value equals, and then the slope, and then in parentheses. Normally it's x minus the x value, so here we have the x variable t time minus 5, because that's the t value. All right, so we're going to go ahead and graph this bad boy. B minus 3 equals 1/2 times t minus. You already have this written down. We need to label the axes. We got a t-axis and a b-axis going on here, and we need to scale it. Now, in this case, it's not so bad. The numbers are nice and small, so we can actually just go by ones. You still need to demonstrate that you're scaling it. You only need to do it once on each axis. You don't have to do the first box. You could go all the way out and say, hey, look, the last box is 10. Or the middle, you could say, hey, it's 5. If you want to be extra annoying, you could go into negative land and say, hey, look over here, 3 boxes over backwards, it's -3. But somewhere you need to have it scaled. So there we are. Go ahead and put a dot down for your point. That's 5, 3. And then a slope of 1/2 going forward. Boom. There we have it. Okay, last example. This one is faster, but not necessarily easier. We have a Piotr. He's he's providing pencils and calculators to his students. A box of pencils, $3. Calculator costs $12. He has 100 bones to spend on supplies. So we have to define 2 variables. So first of all, as usual, we need some kind of independent variable. The things that are changing here are the number, the pencil situation, I guess, and the calculator situation. So we'll go ahead and make the pencils the independent variable. And when I say pencils, I mean actually it's the number of boxes of pencils. You got to be super careful and make sure that you often need to include number of in front of the thing. If you said P is pencils, that's not really true. You're not going to graph pencils themselves. You're going to graph the number of the pencils. Oh, adults are annoying. Okay, dependent variable. That's the other variable. And in this case, since we've already used pencils, we're going to have to talk about calculators. So, C, and here again it's number of calculators, because when you graph it up and down the y-axis, or I guess now the c-axis, it's not going to be calculators you're putting down. You're going to be putting down numbers of calculators. Okay, that's that. Now, in the first 2 examples, I actually was slightly different in my words, and I said, look, the independent variable changes no matter what, and the dependent variable changes based on the changes in the independent variable. That's annoying to think about. The dependent depends on the independent. However, here, there's nothing magical about the pencils and the calculators, like one of them happening automatically and the other one happening as a result of that. So none of them really depends on the other. The point that I'm trying to make right now is that in this kind of case, it is not obvious which one's independent and which one's dependent, which means you actually have a little more choice for which one you want. Okay. To make the equation, though, it's just 3p plus 12c equals 100. Each box of pencils costs $3. Each calculator costs $12. And if you add up the pencil cost and the calculator cost, it has to be 100, because that's all Piotr has for his school supply budget. Okay, so for a graph, the equation 3p plus 12c equals 100. And this is in kind of standard form style, so we can do it faster by doing intercepts. Make a graph faster by doing intercepts. So if c is 0, we're really talking about 3p is 100. If you divide by 3, you get p is 33.3-ish. Okay, so if he doesn't buy any calculators, he could buy 33 1/3, apparently, boxes of pencils. And then, on the other hand, if all his money goes into calculators, meaning he has no money in pencils, then it's just 12c equals 100. If you divide by 12, then you get c equals 8.5. So that's okay, 8.5 calculators. So let's see, we got a p-axis and we got a c-axis, and then you already know you need to get up to 33 1/3-ish on the p-axis, so you might need to go by 5s there. On the c-axis, you only have to get up to 8.5, so 1s would work. Remember, you do not need the same scale, for each axis, right? You could have one scale on the horizontal axis, a different scale on the vertical axis. Okay, so now we've got some dots, right? We got p is 33 1/3, and c is 8.5, so there's the c-intercept up at 8.5, all the money on calculators, no pencils. And here we've got the p-intercept at 33 1/3, all the money in pencils, none of the money in calculators, and then, there's our line, and there, frankly, should be your happiness. Hey, it's been a wild ride, but thank you for watching, and please let me know if you have any questions. Bye-bye.